Hello, this video will answer the question how to solve a system of equations using augmented matrices. And the equations we're going to begin with are on page 145, number 1 of the Forster's Algebra 2 and Trigonometry. So here we have a system of equation with two variables, x and y, and ordinarily we would use algebraic strategies to isolate one of the variables. Possibly we would multiply these by a 4 and these by a -3, thus getting a 12 and a -12, add down, thus isolating or eliminating rather the x variable, solve for the y variable, substitute that back in and find the x solution. But in this case we're going to use matrices. What is a matrix? A matrix is an array of numbers. And in our case, we're going to use the coefficients from our two equations. So we are going to solve using a matrix by taking the coefficients. Now, keep in mind that this is x and this is y. So these are 3 and 4. Those are x's. And these are 8 and 5. Of course, keep in mind, neither of these are negative, so there's no negative here. But if there was, you would include that. And we're going to call this matrix A. These are the answers that you get for these particular equations. We're going to make a second matrix out of that. We're going to call that 54 and 38. That matrix will be B. Now very quickly, matrices are numbered or named by their down and over. Down is a column, over is a row. So this is row 3, 8, this is down 3, 4. So if you keep in mind DO, down over, this is a 2 by 2 matrix. You can tell it's a square, but it's 2 this way, 2 that way. This is down 2 and over just 1. So this is a 2 by 1 matrix. We're going to call this matrix B. Now in terms of matrices, what I want to get is where I have a 1x equals some number and a 1y equals some number. And so when I'm all done, my matrix I want to have look like this. 1, 0. I want a 1 in the x place, a 0 in the y place, and a number here. And I want a 0 in the x place and a 1 in the y place and a number here. Think of a computer, and 1 is an answer, 0 is not an answer. So this would be x equals A and y equals B. Here's my x column and my y column. Okay, this is what we're ultimately going to be looking to get. In the meantime, we are going to get an augmented matrix we're going to call C. And you'll see when we use the calculator, it really just kind of puts these two matrices together, but it augments them. And so we'll have our x's, our y's, and our answers to them. Now we can't just enter them that way, so we have to actually augment the matrices. And let me show you how to do that. Okay, so first we're going to enter in matrix 1, we're going to enter A, then we're going to enter B, then we're going to augment them and store it to C, and then we're going to ask the calculator to do what's called an RREF, which basically is a reduced row echelon form, and it's going to then look like this. Okay, I'm excited. Let's see what we get. So the first thing to do, of course, is get your graph calculator on and ask it to go to matrices, which is a second function on the x to the -1, which says matrix. And we want to edit. To enter data, we have to edit, and in A, we choose A. Okay, so in my calculator, it says 1 by 1, but as you know, A is a 2 by 2. So we have to tell the calculator to make that a 2 by 2. So all I do is just enter 2, enter that, and it moves over there by 2, enter that, and you can see that it has now opened up a 2 by 2 space here. Now the position of my cursor is at the 1, 1, and so that first element is a 3. So we're going to put 3 there and enter it. Then it moves over to row 1, column 2, and that is an 8. So basically we just enter what we have here as our matrix. Okay, now I'm in row 2, the second row, column 1, the first column, columns go up and down. That is a 4, enter 4. And now I'm in row 2, column 2. Row 2 down here, column 2 is over here, and that is a 5. Okay, so now we have the elements for matrix A entered. So quit that for now, and then we want to enter the elements for B. So go second matrix, edit, and then scroll down to B. Make sure you go to edit first. Okay, otherwise other things happen. Okay, now matrix B is a 2 down, 1 over. So we have to make sure that up here we have 2 by 1. And if you don't, enter that now, 2 by 1. Okay, and so you see it's really just, one column here. And our numbers are 54, enter that, and 38, enter that. Okay, so there's B. Okay, so now we want the calculator to augment those. So second quit, go back to second matrix, and now we want to do some math. We want to augment, which is number 7. We want to put these together in a special way. Okay, enter number 7. Now it wants to know what would you like me to augment. Okay, so we want to augment A with B. So we go second matrix, choose A, and it enters A. Comma, which is right above your 7 button, comma, second matrix, choose B, which you can scroll down to or press the number 2. Now it says augment A, comma, B, close the parentheses on that. And what we would like it to do then is store that to C. Okay, so way down here above your on button is store. You get a little arrow. And then we're going to say second matrix number 3, C. Okay, so what do we have? We have augment A to B, augment A and B, and store it to C. Okay, so let's enter that. Okay, and now what do we see here? We see pretty much these elements, 3, 8, 54, and 4, 5, 38, but they're in there in a special way. So now what we want to do is ask the calculator to do the RREF, which represents the reduced row echelon form, so that we get this right here. We have a 1 in the X position and a 0 in the Y position and a number here, and a 0 in the X position and the 1 in the Y position and a number here. Okay, so let's do it. So second matrix. Now we would like to do some math. So scroll over to math when we want a calculation done. And you have to scroll down a little bit. It's not very far. It would be RREF. In my case, it's B. But just scroll down with your arrow, your down arrow, to get down to RREF. Choose that with your enter button. But now you want to say RREFC. So you have to say second matrix, and then choose number 3, which it enters C in there for you. You can close the parentheses, you don't really have to, and let's enter and see what we get. Okay, so look what we have. We have 102 and 106. Okay, so I'm going to adjust my A and B here. A and B are 2 and 6. Now what does that mean? That means that X is 2 and Y is 6. Now let's see, would that check? So let's put a 2 and a 6 here. 3 times 2 is 6. 8 times 6 is 48. 6 plus 48 is 54. That works. If 4 times 2 is 8, 5 times 6 is 30. 8 plus 30 is 38. So yes, indeed, these are the solutions to this problem. So we've used it in augmented matrix. We entered the coefficients of the variables in matrix A. We entered the answers in matrix B. We augmented them and stored it to C. And then we used RREF, the reduced row echelon form, to get the 1, 0, 0, 1 for X and Y, X and Y. So this is X equals 2 and Y equals 6. And this can be done for many variables. In other equations, you might have an X, Y, and a Z. You would simply, though, say then you have a 3 by 3 A. You would still have a 3 by 1 B. You would augment them, get a 3 by 4 C, and then you would have your reduced row echelon form over here with a 1 0 0 and a 0 1 0 and a 0 0 1 for X, Y, and Z. Okay, I hope this helped, and please do email me if you have any questions whatsoever. See you soon.